Good day, everyone. I go by the name of Hlungwanevunwinyi. Today we are going to focus on equilibrium of particles on mechanical technology. First of all, what you have to know is the definition of equilibrium of particles. Equilibrium of particles occur when all forces acting on the particle balances each other so that the particles remain at the rest or move with a constant velocity or no acceleration. If we say the object move with a constant velocity, that means our A must be equals to 0. That means there is no acceleration. Okay, we have two conditions for equilibrium to take place. Number one, the sum of horizontal forces must be equals to 0. Number two, but the sum of forces of vertical forces must also be equals to 0. That means this condition, in order for equilibrium, the sum of vertical forces must be equals to 0 and the sum of vertical forces must be equals to 0. Okay, let's take a little example here. In order for us to understand, let's take a little example. Okay, let's say we have a Cartesian plane like this. We have a force going this way and another force going this way. We can call this one F1 and this one F2. We have to provide two components of this force in order to be vertical and horizontal. So we will do like this. Let me use another color so that we will see what this is the components. Okay, this is the component is number one. This we can call this F1 x j. This we can call this one F1 x I. Here is not x, it's F1 y j. Here we can call this F2 x I. Here we can call this F2 y j. Okay, this is our what? Our components. So what we are trying to say is that sum, let me use this black pen. What we are trying to say is that sum of forces at x must be equals to 0. Sum of horizontal forces must be equals to 0 and sum of vertical forces must be equals to 0. And now we have our vertical forces and our horizontal forces. Okay, now we are going to generate our formula. It will say sum of fx plus sum of fy is equals to 0. That means if we add the sum of vertical forces and the sum of horizontal forces, it will give us 0. Okay, I hope we are clear there. I hope we are clear. Okay, now we are going to free body diagram. Free body diagram. First of all, you must know the definition of free body diagram. Free body diagram. A free body diagram, just know what is the what is the point. Is a free body diagram is represented by a point which shows all forces acting on a what, on an object. It shows all forces acting on an object. Let's say we have an object like this. This is the surface area, and is the object is in contact with the surface area. Then they say draw the free body diagram. That means we have to provide all forces acting on this object. That means we will have normal force, which is always perpendicular to the what, to the surface, and always we have weight. Always we have weight. We'll have like this, normal force and weight. Weight, normal force. You see, we have represented all forces acting on this object. Okay, let's say we have it like this. Is the force this side, and I say draw the free body diagram of 5 kg. Now we're going to represent our free body diagram using what? Using dot. Okay, first of all, you must know it's in contact with the surface. That means it will go normal force and Fg will be provided. Therefore, this will be weight. Then we have normal force and weight. And we also have the force that is going this side. We can call it T. Attention. So this is how we draw our free body diagram. Free body diagram shows all forces acting on an object. Yeah, if you know that, you know the definition of free body diagram, and you will know how to apply free body diagram. Okay, for now, let's take an example. I have many examples with me here, so we'll do them together in order for us to understand better and better. Okay. Okay. Here is number one. It says problem number one. We are here now. Yeah. Problem number one. The crate has a weight of 550 Newton. Determine the force in each supporting cable. When we talk about the what, we talk about the weight. Just know weight is equals to mg. This, if they didn't give you, they give you mass. This is always there, is 9.81. So it's simple. Now we have what? 550. You can easily get what? Get m. But this is the story for another day, that we are not there. Okay, they say we have weight of what? Of 550. So now, first of all, we have to do what? We have to draw. We have to draw our what? We have to draw our free body diagram. First of all, when you wanna approach the question, you have to draw the free body diagram. You see, I cheated. Free body diagram is represented by the what? By the dot. Therefore, there is a weight that is going down. Must be perpendicular to this. There is a weight is going down. We also have the force AC. This is the force AC. Here is A. Here is C. Here is D. We also have AB. Here is AB. This is our free body diagram. This is our free body diagram. That means we are now know all forces acting on our object. All forces acting on an object we know. Okay. Now we are going to have our Cartesian plane. Let's say we have like this around, and a force going this side, and a force going this side, and a force going this side. Here W is equals to 5, 5, 0. Therefore, here there is an angle of that. That means we also need here to construct here, even here we release two components. Here are two components. This is A. This is what is C. This is what is B. We can call it TB and TC. Therefore, here on this we have a small triangle here, where here is what is 3 and 4, and here is what is 5. Okay, that means here on this side, let me use another color for us to understand. On this side, on our component X and Y, here we are going to say is Y. Here is T C Y. Here is T C X. I hope you understand, because this is TC, but we are now doing at the component. This is TCY and TCX. This is on X axis, this is on Y axis. Okay, on this side we are also doing the same. Here is T B Y, even here is T B X. Here is on the axis, X axis. Here is on Y axis. The component is at Y axis. Here is on X axis. Okay, now we have made things simpler. What we have to do is that we have to say, we have to come on this triangle, which have hypotenuse, adjacent, and opposite. We are going to use, so always know that we are going to use socatone, we are going to use these trig ratios. Okay, we are coming on this angle now, TC, on the force of TC. Now we want TCX. Okay, TCX will be TCX divided by TC is equals to, what is TCX is 4 divided by 5. Is 4 divided by 5 is adjacent divided by 5. That means we have 4 divided by 5. Therefore, after that, we are going to do what? We are going to make TCX the subject of the formula. That means TCX will be equal to 4 over 5T TC. We are now done with what? With TCX. Okay, let me see. Okay, now we are going to find TBX. When we check here, TBX is on this side. We have this angle 30 here. We need what? We need TBX. That means it will be TBX is equals to TB cos 30. But when we check, if this was our was our Cartesian plane, here is x-axis, here is y-axis, this is going to positive, but this is going to negative. That means our x value there is negative, but here our x value is what? Is positive. So we are going to put it with negative. We are going to put it with negative. That means we are going to say TB is equals to negative TB cos 30. I hope all of us will understand that one. How did I do it? Okay, now because we know that sum of forces x must be equals to 0. Now we are going to add the forces. Now we are going to say TCX plus TBX is equals to 0. Now we substitute, we get 4. No, we don't use 4. Let's make things simpler. We say 4 divided by 5 is what? 0.8. We use 0, 0.8 TC plus what is we'll go again here. We use this one. Here we'll use this one. Therefore we are going to say cos 30 is 0.88. Then we're going to say 0.866 B TB is equals to 0. Is this? But don't forget we have negative. Okay, I think it's now understandable. Okay, because we have negative, we are going to multiply negative with positive. It's going to give us a negative. That means we will be left with 0.8 TC is equals to 0.866 TB. We multiply negative with positive and we take this to the other side. It gives us positive. Then we make TC subject to the formula. We divide by 8. We divide by 0.8. Therefore, we get our TC. Then we say TC is equals to, therefore, divide by 0.8 is 1,0825 TB. We can call this equation number 1. This is our equation number 1. Okay, now we find our horizontal component. Now we are coming to y. Okay, let me do it like this. Okay, if you see here we have TCY. TCY, will be equals to TCY divided by TC. It will be opposite over hypotenuse. That means it's equals to what? Is equals to 3 divided by 5. That means it's going to be TCY is equals to 3 divided by 5 TC. Because we do what? Is 3 here. Is 3 here and 5 here, and we have TCY, we have the hypotenuse. Therefore, that's why we are going to use this one. Okay, even here at TBY divided by TB is going to be sine 30. It's going to give us sine 30, né? Therefore, we do what? We do like cross multiply. Our TBY is equals to, oh, my pen is not writing. Is equals to what? Is equals to TB sine 30. I hope all of us will understand. Okay, let us go back there and write it proper. Okay, now we have our equation number 1. Okay, let's go back. We have find that TBY is equals to what? Is equals to TB sine 30. That means our TCY is equals to 3 over 5. 3 over 5 what? TC. So we are going to do what? We are going to equate the two. We are going to use sum of forces at y is equals to 0. That means if we add up TBY plus TCY plus weight will give us 0. Again, even this one is on y-axis, is going down, but it's negative. When we apply it, we will put negative. Okay, our TBY is what? Our TBY is when we say is sine 30, 0,5 TB plus, what is our TC? Is 3 over 5. 3 over 5 is what? Is 0,6. 0,6 TC minus 550 minus 550 is equals to what? Is equals to 0. Therefore, to make our life simpler, we have to say 0,5 TB plus 0,6 TC is equals to 550. Is equals to 550. Okay, we are going to insert this. We can call it equation number 2. So we have our equation number 1 up there. Here is our equation number 1. If we still remember, here is our equation number 1. We are going to substitute TC where we see, we are going to substitute 1,9825 TB when we see TC. Okay, Again, now we have our equation 2. Yes, our equation 2. Yes, our equation 2. So here we see TC. We are going to equate what? We are going to put 1,0825. Then let us write. Then 0,5 TB plus 0,6 what? We are going to substitute by 1, 1,0825. 25 what? TB. Okay. Therefore, here we are going to say 0,5 plus 0,5 TB plus, we are going to multiply these two, multiply by 1,08225. It's going to give us 0,64, 0,6495 TB. Don't forget here there is what? 550. Okay, now we have these two. We are going to add with 0,5 because they are like terms. It's going to be 1. These two are like terms, ne? 1,1,4,9,5 TB is equals to 550. Therefore, we are going to divide by 1,1,4,9,5 divided by 1,4,9,5. Therefore, our TB is equals to 478,46. Therefore, our TB to the nearest whole number is 479 Newton. Okay, we are not done because we still need TC. Okay, we are going to use that equation. Where is that equation? Equation number 1. Equation number 1. Yes, equation number 1. Now we know TB. We know TB is equals to 478,4,46. Now we are going to do what? We are going to equate here and say TC is equals to 1,0825 multiplied by what? Multiplied by 478,46, which is TC. Therefore, our TC will be equals to multiplied by 478,46, which is equals to 517,93. Therefore, TC will be equals to 518 Newton. Now we are done with our TC. We find our TC. Okay, let's go to another question for us. In order for us to understand, we have to do another question. Let me erase this one. I hope we understand, guys. Because I make things simpler there. I make things simpler for us. Okay, let's come back here to the question and see which one are we doing. Okay, let us do problem number 4. I won't follow this. I will just do problem number 4. Okay, now we are at problem number 4. Okay, we know that first of all what we must draw the free body diagram of the what of this what we say. Okay, we are on our problem number 4. So on problem number 4, when I draw let me increase this, it will be like we have a what, a weight. A weight is equal to mass multiplied by gravity. A mass multiplied by gravity. Therefore, we have a force that is going like this, which we can call it BEB. Therefore, after this, I think this will make us the things simple. And we also have a force going down, but this rope is continuous. Here is the object, which is 40 kg. This object C. So now we are going to do what? We are going to find our weight on 40 kg. Our weight is equal to mg. Therefore, is 40 multiplied by 9.8, 9.81. Okay, then we use our calculator and get what? 40 multiplied by 9.81. We get what? 3 get 3 get 3 9 9 2.4. This is our answer of what? Of weight at block of C. Here our weight here is what? Is 3 9 92.4, our weight. So that means a EBC, like this rope is continuous here. That means if we have the weight that is going down here, which is this one, that means even this TB is also equal to what? Is also equal to the weight. Is also equal to the what? To the weight. Why? Because they have the equal magnitude, but in different what? In different direction. Therefore, that means here at TB we also have the what? We also have our answer. That means our TB is what? Is also 392.4. So if we have it like that, our TB as 392.4. Yes. Now we are going to see agree now. Let me show you here. Let me erase this thing in order for us to understand. Now we have a free body diagram, not a free body diagram, but a Cartesian plane like this. We have what? We have our weight, which is going this side, our weight. Then we have the angle here. Therefore, we have to restrict this angle to be into components like this. Now here, because they say we must find what? We must find the mass of the cylinder C. Of the cylinder C. If the mass of cylinder C is 40, here, the mass is 40, we'll find the weight. Determine the cylinder A in order to hold assembly position of what? In order to have a position shown. That means we are going to find the what? The mass of A here. So we are going to forget about the horizontal forces. We are going to focus on our y values. Now we are going to do our what? Our component. That means this is going to be TB. We are going to call it TB. Therefore, this will be TBY. Therefore, we forget about TBX. Let's forget about TBX. We are going to focus on TB. But remember, here we have what? We have 30 degrees. Therefore, if it's like that, we are going to equate all forces at y must be equals to what? To 0. What are all forces at y? It's going to be Ft tension By is equals to what? Tension By plus weight is equals to 0. Why? Because we have a free body diagram like this. This is our weight. Then we restrict here in order for us to two component. This one now is y. It comes here. Then we are going to focus on that. We are going to erase all of them. We left with this one. But we know that this is what? TBY. This is weight. That means we are going to equate them. And TBY is going to be TB our TBY is going to be TB sine angle, and our angle is what? Is 30. Let me just put sine 30 plus what is our weight? We have calculated our weight. That is, we didn't calculate. Okay, we are going to say we didn't have our weight is equals to 0. Okay. Therefore, what is our TB? We have already calculated our TB. Our TB is 392.4 because we calculated it when we say weight is equals to TB but in different direction. Sine 30 plus we are going to use what? We are going to use, what is weight? Weight is mass multiplied by gravity when it's equals to 0. But we need mass indeed, but we have this is 9.81. Therefore we're going to equate them. Separate this on calculator. We say 392.4 to make things simpler. Sin 30. Give us 1962 plus 9.81 mass is equals to 0. Therefore, because weight is on is going down, it's going to be negative. I forgot, don't make mistake guys, it's going to be negative. Therefore we now transpose, is going to be 1196.2 is equals to positive. Now it's positive because we bring this in this 81 meter. Weight is always downwards, is positive. It's going to the what? Okay. Now it's maths. It's not mechanical, it's maths. We are going to say 9.81 divided by what? 9.81. Therefore we get our mass. Our mass is equals to, then you say answer divided by what? By 9.81. We get 20 what? 20 kilogram. Don't forget the SI unit, 20 kilograms. Now we are done with our question. You see how it was simple? This question was simple because we were going to focus on our what? On our free body diagram, like this, because we have this and this. We need weight here. Weight is mg, and we have what? We have the angle here, which is 30, and we have a component here, and a component. We need fby. So fby will be fb what? Sin 30. Therefore we are done. We're done. Okay, let us go to another question. Let's go to another question. Okay, now we are on problem number 3. If the 5 kg block is suspended from a pulley B and seg of the cord D, determine the force in a cord ABC. Okay, now our free body diagram, it will be like this. You know guys, always you have to draw your free body diagram, and free body diagram is represented by what? By a dot. Okay, look, my dot is big, and you go like this, then this is C, then it also goes like this is A, then it goes down like this, which is what? Which is D. Okay, now we see where we have this free body diagram. Okay, we are going to have our Cartesian plane as always. Then we have a force like this. We also have a force like this. We also have a what? A weight. So we are going to do what? We're going to put our what? Our verticals. Our component. Our component. Here is what? Here is C. Here is C. Is TC. Here is what? Is A. Here is A. Therefore, if it's A, we know that the distance from here to here is what? Is 0. No? The distance from here point here is 0.4. That means all here but here will be 0.2. Okay. 0.4 divided by 2 is 0.2. That means we know from our y-axis to there. We know. That means when we need the distance, we are going to say 0.4 divided by 2, which is what? 0, 2. 0, 2. Okay, fine. Now we know that we have 0.15 meter and 0.2. Okay, let's see. Our box is like this. Here is 0.15 and here is 0.2. Our box is like this. Okay, now we are going to do what? We are going to say, okay, that means we are going to say this is 0.2 and this is 0.15. Okay, we have given that our W is equals to what? Is equals to 5 multiplied by what? Multiplied by 9.8, because they already give us mass. If we have mass, because we know that W is equals to mass multiplied by what? By gravity, and gravity is 9.81. Okay, then we do our calculator. We say W is equals to what? Is equals to 5 multiplied by 9.8. 5 multiplied by 9.8. Then we get the answer is 49.05 Newton, because we are measuring what? We are measuring what is this? We are measuring forces. Therefore, since the code AB is continuous, let me show you the code AB is continuous. Okay, this code is continuous. ABC, this code is continuous. This code is continuous. That means we are going to say TB here, TB is equals to TBC, tension BC here and here, they are equal, is equals to what? TBA. Why? The chord are what? Are continuous. Therefore, we can call this T. We represent this T. Okay, therefore, we are going to say for angle, we are going to use what? We are going to use tan 1/4. Okay, we know that tan is what? Tan why is not working? Tan 0.15 divided by what? Divided by 0.2. Therefore, we shapara our calculator. sharpen our calculator here. Then we get our theta as what? As 36.87. We get our theta as 36.7. Then we are going to say sum of forces at y is equals to 0. Then we equate the forces that is equals to 0, which is our t. Again, we now call them t sine theta plus t sine theta minus w is equals to 0. Therefore, we know that this and this, they are like terms again. They are going to be what? They are going to be 2 sine what? They are going to be 2 t sine theta, because they are equal. 2 sine theta is equals to w, is equals to w. Okay, therefore, if it's like this, we are going to know that our w is what? Is 0, our w, our weight is 4,905. We have calculated it long time ago. Then we are going to put 36,87 here. Then we find t. So we are going to make t subject to the formula. We are going to divide by what? Let me change the color. We are going to divide by 2 sine theta. 2 sine theta. Therefore, divide by 2 sine theta. Therefore, after that, we know that here will be t. What is w? Is 4. Our w is 4,49,05 divided by what? 2 sine. What is our angle? Our angle is 36,1,87. Is that? Therefore, we have to get our what? We have to get our t. Okay, what is our t? Our t is equal to what? Is equal to 40,87. That means what we have said is that what we have said is that our TB is equals to, our TBA is equals to TBC is equals to T. Therefore, is equals to what? Is equals to 40 Newton. Now we are done with our problem number 3. Now we are going to problem number 2. Okay, here we are doing problem number 5. Therefore, we have given that determine the tension in cable AB, BC, and CD necessary to support 1 kg and 15 kg traffic lines at B and C. At B and C. At B and C. At B and C. Here's B and C. Okay, they say the weight at B and C is question. Therefore, here at B, we have what? We have a weight. Here at B, we have a weight of what? weight at B. Let me write it like this. Weight at B is equals to 10 multiplied by 9.8 what? Then we say is what? It's 98.10. 98.10, not 98.10. Therefore, we come for weight at what? Weight at B. Weight at C. What is our is 15. Our mass is 15. That means we are going to say 15 multiplied by 9.81. Then we use our calculator, we get our mass, our weight, which is 417,15 Newton. Even here we must not leave that is what is Newton. Okay, number 2, we are going to join the equilibrium B. We are going to join equilibrium force meeting at B. Okay, when we draw the free body diagram, we are going to join BC. Therefore, our free body diagram is like a dot. Here we have joined BC. Therefore, it goes like this. Our B, then it goes like this. Our A, then the combined weight is going down like this. Combined weight with what? BC. Yes, it's going down like this. You are going to use like this one, eh? Okay, after that we are going to say sum. On this side, you see this side, is 30. Not 30, man. What I'm saying is 15 degrees. It's 15 degrees Celsius, ne? Therefore, we can find the direction of the height towards the TB. Then we are going to say TB is equals to what? TB not is equals to TB sine 15 minus WB. Okay, we are focusing on B is equals to 0. Why? We use that word sum of forces at Y is equals to 0. But where? But on B here. We have weight, we have TAB. So we are going to use that. Therefore, we get that TBA is what? Is WB divided by what? Sine 15. What is our sine 15? Our sine 15 is 0,225. We have the what? We have WB that we have calculated is 98.10 divided by sine 15 divided by sine 15. Therefore, we get our answer. We get that our TAB is equal to 379.029. Okay, we run to the nearest what? We are going to write it to the nearest whole number. It's going to be 379. It's fine. Then we are going to deal with sum of forces X. They are equal to what? They are equal to 0. Therefore, we are going to use what? TBC is minus TAB cos 15 is equals to what? Is equals to 0. Therefore, we are going to say TBC minus TAB cos 15 is equals to 0. Therefore we do what? We say TB C is equals to TAB cos 15. Therefore we know that cos 15 is that. Therefore our TBC will be equals to what? Will be equals to 3661 Newton. That was the calculator. Therefore we join equilibrium at C. Therefore we are going to say TCD cos theta minus TBC is equals to what? 0. Therefore we are going to lead to TCD cos theta is equals to TBC. Then we what? We substitute. We get what? Our theta is going to be tan angle is equals to WC divided by TBC. Then we have WC. We have WC. What is WC? WC is what? Is 144. Is 147.15 divided by what? We are going to divide it by what? TB. TB, which is what? Which is sine what? Sine theta. Therefore we get our sine, which is what? We get our theta. Our theta, when we calculate, it will give us what? 21,90. Therefore we come here, our TCD is equals to 147,15 divided by 0,3729. Therefore now we are done. Therefore we calculated that our TAB is equals to what? 379,03 Newton. Therefore our TBC is equals to what? 366,1 Newton. Therefore our TD is equals to 394,558 Newton. Then we have our angle 40. Our angle is going to be 21,9 degrees. Therefore now we are done with what? Now we are done with number 5. Okay, I can easily, I've done this question first, so let me explain. Okay, since they have given us weight, what? Weight. Since they have given us mass, they say mass at B is equals to 10 kg. Whenever you have mass, always know that you will get weight, because we have the constant. Therefore we are going to find weight at B. How? we are going to say mass multiplied by gravity. Therefore, what is our mass is equals to 10 multiplied by 9.81. Therefore, we get what? We get the answer. What is 10 multiplied by 9.81? It's going to be 98.1. It's going to be 98.1 what? Newton. I think we understand that. Therefore, we have okay. Therefore, we have what? We have that at C, the what? The kg or the mass is 15. Therefore, the WC, the weight at C, is equals to mass multiplied by gravity. Therefore, our mass is 15. It's going to be 15 multiplied by 9.8. It's going to be 15 multiplied by what? 9.8. It's going to be 15 multiplied by what? Multiplied by 9.81. Therefore, you get the answer. After that, we are going to draw a free body diagram here. I think you will follow. Here is the free body diagram. It's going to be like this. It's going to be like this. It's going to be like this. What's up? It's going to be like dot. Free body diagram is a dot. A dot. Therefore, an angle this side, and rotation this side, and a what? And a gravity. We combine BC. Here is BC. Is BC because they are the same point. Therefore, there is the force this side. There is the force this side, and this force is continuous. The force is continuous. That means A B is equals to C D. Here is B, here is C. This force is continuous. That means they are equal here. They are equal. Now, I think you understand. Therefore, we have the angle here, which is 15. Therefore, we can find like this. Then it comes like this. So, I think now we understand. So, we are going to, let me erase. Then we are going to write. We are going to focus on our last question. We are going to focus on our last question. Let me erase this. Okay, this will be our last question. This will be our last question, number 2. Okay, we are going to draw a free body diagram represented by a dot on number 2. Okay, here we are drawing our free body diagram. We have the force going like this, and the force going like this, and we have the what? Weight, like that. Okay, step 1, we are going to say like 2t sine theta is equals to W. Why? Because we have the continuous rope, we have the continuous tension here. That means AB and AC are equal. Okay, as I was saying, Uri, as we see that this rope is continuous, we are going to say T2T is equals to W. Okay, 2T sine theta is equals to W, because this is the what? This is the component. Okay, because we are going to make sine, we are going to divide by 2T in order to make sine, the subject of the formula. Is going to be sine theta divide is equals to W divided by 2T. Therefore, we know that our weight is what? Is 3.5. What I'm doing now. Our weight is what? Is 3.5. Therefore, our weight is equals to 3.5. Then our T is equals to 7.5. 7.5 kN. Even my weight is 1 kN. Therefore, we are going to say sine theta is going to be 3.5 divided by 2 multiplied by 7.5. Therefore, we get our answer as follows: as sine angle is equals to 0, 233. Therefore, because we need an angle, we are going to say inverse theta is equals to inverse what? 0,2334. Therefore, we are going to get our theta. Our theta is going to be 13.5 degrees. Now we find our what? Our theta. We have our theta. Now number 3, we are going to our horizontal length. That is 5. Therefore, we are going to divide it by 2. Therefore, it gives us what? 2.5. What I'm saying is this. Here, okay, our 3.5, we use it, and 7.5 and 3.5 here, we're using this. Okay, now we'll talk about 2.5, because we have found that our 3 meter here, we are going to divide by 2 here. That means this side from here to here is what? 3 divided by 2 is going to be 1,5. Here is 1,5. 1,5. Even here is 1,5. We have this angle now. Now we can find here and here. How are we going to find them? We are going to say our tan angle is equals to h divided by 2.5. Therefore, because we need what? We need h. We are going to cross multiply. h will equals to tan. We cross multiply tan angle multiplied by 2.5. Therefore, we get our h. Our h will be h is equals to 2.5 tan 13.5. Then we share our calculator. We have our h as what? As 0.60 meter. Now we know our height. Therefore, step 4, we are going to say LAB is equals to what? LBC is equals to 2.5 divided by cos it. Why I said this? Because that is a continuous, ne? We are going to use that. Okay, let me erase here so that we will understand proper. Okay. Now we are going to say what? We are going to say LB is equals to what? Is equals to not LB, no, it's not LB. Let me see with what. Yeah, it's not LB, it's AB. LAB is going to be 2.5 divided by what? Divided by cos. Now we know our angle is 13.5. Okay, if our angle is 13.5, we are going to say 2.5 divided by what? Divided by 0.972, which will give us what? Will give us 2.75 meter. Then the total length will be ABC is equals to 2LAB. Therefore, we are going to substitute 2LAB is 2.57. Now we are coming there. We are approaching the answer. Then it's equals to what? It's equals to 514 meter. Now we get our answer. Okay. Therefore, we have said that the first weight, it was 3.5 kN. Therefore, after that we talk about T is 7.5 kN. We have given this one was given to us. Therefore, we have the what? The angle we get is 13.5. Okay. After that, we get the height. The height of the what? Of above was what? The height was let me use black. The height was 0.6. Then we get the what? The total length. Total LABC, which is what? Which is 5. Which is 5.14 meter. Yes, now we get the what? We get the large total. Okay, now let me erase here so that I can explain, and soon we'll end up this lesson. I wanna make things easy for you. Let me erase this thing, then I start explaining for you. Okay, now we are on recall. We talk about that when we have to calculate the equilibrium of particles, we must draw the free body diagram. Free body diagram. We must what? We have the condition which says sum of forces at horizontal forces must be equals to 0. There must be sum of vertical forces must also be equals to 0. Therefore, we speak about the forces which goes like this. We have to provide two components like this. If this is F1, this is F2. This is going to be F2y. This is going to be F2x. This is going to be F1x and F12. If we have given an angle, we will use our trig ratio. If we have given our hypotenuse and opposite and adjacent, we are going to use the what? Sometimes we are allowed to use, what is this? Pythagoras. If you are able to do, we are going to use hypotenuse here. You use like this. You are allowed or to use what? Staccato, or you are allowed to use staccato. Yes, okay. Two. This is what at the beginning I tell you is what is sine, which is what opposite over hypo. Then we have what? We have cos, which is what? Adjacent over what? Over hypo. Then we have what? We have tan, which is what? Which is adjacent over opposite over adjacent. I swapped. Okay, let me do like this. Opposite over adjacent. Okay, now we talk about this. So what we have to know is that sum of forces at x must always be equal to 0. Sum of horizontal forces must also equal to 0. Even vertical forces must also equal to 0. This is the condition for equilibrium to balance. That's why they say equilibrium. Here at the beginning we say that when we know that, we must first know that the definition of equilibrium. The equilibrium of particles Equilibrium of particles. Equilibrium of particles occurs when all forces acting on the particles balances each other so that the particle remains at rest or move with constant velocity. The whole thing that we're doing from problem number one, from problem number from problem number one to problem number five, we were balancing each other particles. We were balancing each other particles so that the particle remain at the rest or move with a what? A constant velocity. That means our acceleration was what? Was zero. And all we were using the condition that the sum, we were using the condition of the what? Of the sums. The sum of x is equals to what? Is equals to zero. Even the sum of what? Of y. The sum of y, they must also equals to zero. And all we were using the what? We're using the this thing. If the angle is like this, the angle is like this, we have to restrict, we have to do the components, we have to do the component. If we give an angle, we know how to use it. If we were given the side, we know how to use it. So sometimes we will be given the distance from here to here. Let's take the say is 10. Therefore, when I know from here to here is what is 5. Even here is 5. So is that we need to apply this in order to understand. We must know the condition first. We must know even the what? Even the definition. You must know even how to draw the free body diagram of our sums. So if you know how to draw the free body diagram, it's child. Now you know how to answer because you know the all forces. The definition of free body diagram, it says it shows all forces acting on the what? On the object. All forces acting on the what? On the object. Free body diagram. Okay, let me write it. Free body diagram. It represents all forces acting on a what? On the object. That means if you draw the free body diagram, you know all forces acting on an object. It's either you can draw the free body diagram. Let's say we have like this. Let's say we have they say this is our object, is f1 and f2 and wait. So to draw this free body diagram, now this is now a free body diagram. It's now you have to do what? You have to represent it by a dot. A free body diagram is represented by what? A dot, not a circle. Then you say what? We have this. Then you say it is f what? F1. Then you have what? Wait. Then you have what? Another f2. Then you do what? You construct. You use what? You use f of x of y. Then here is f of x. Here is what? F2x. Here is what? F2y. Now if you know these two, all sums will be easy for us. All sums will be easy for us. Okay, I think now we are done with our sums. I think now we are done with equilibrium of particles. Okay, let me erase this. Okay, now we are done with our what? Equilibrium of particles. Bear in mind, just note the definition. Equilibrium of particles occur when all forces acting on the particle balance each other so that the particles remain at rest or move with a constant velocity or no acceleration. we have the condition for equilibrium. The sum of all horizontal forces must be equal to 0, and the sum of vertical forces must be equal to 0. Okay guys, see you next time. Now we're done with our equilibrium of particles. Thank you guys for participating. Thank you guys.